What's going on, guys? In this video we are going to see some examples on de Broglie wavelength problems in chemistry. Now let's look at the first problem. This is first, this is second. Let's look at the first one. What is the speed of an electron that has a wavelength of 250 nanometer? When we deal with de Broglie wavelength problem, the equation we have to use is lambda is equal to h over p or mv. P is momentum is equal to mv, right? So that's why we have mv in the denominator, and h is Planck's constant. Now let's look at the question. What is the question is asking for? What is the speed of an electron? So we have to find what is v value is. V is going to be h over m lambda. Planck's constant always remains the same, that is 6.626 times 10 to the power of minus 34. And the mass of an electron is 9.11 times 10 to the power of minus 31. And the wavelength is provided, that is 250 nanometer. Nano is 10 to the power of minus 9, so we have to multiply 250 by 10 to the power of minus 9, and that's going to give us meter. And if you calculate this one, you're going to get 2909 meter per second. So that's going to be our final answer. Now let's look at the second problem. The second question is asking, what is the momentum of a neutron that has a wavelength of 1400 nanometer? Now instead of mv, we can put lambda is equal to h over p. P is momentum. P is going to be equivalent to h over lambda. H is Planck's constant. That's going to be 6.626 divided times 10 to the power of minus 34 divided by the wavelength, that is 1400 nanometer. 1400, if you want to convert nanometer into meter, we have to multiply this one by 10 to the power of minus 9, and that's going to give us meter. And if you calculate this one, you're going to get 4.73 times 10 to the power of minus 28. Here we are trying to find momentum. Momentum is mass times velocity. Mass is kilogram, velocity is meter per second. So this is going to be the unit for this one. And that's our final solution for the second question. I hope this helps. Thanks for watching.